Hello guys, good to see you back. Once again, I am back with a new OpenCV project. And today in this project, we are going to build a privacy filter with face blur. So without talking too much, let me show you the demonstration what we are going to build today in this project. As you can see in this example, it tracked my face and add a blur mask to my face. And when I move my head, it also move with that. It is live face blur privacy filter. You may see this kind of blurring effect in various news channels. They hide the faces. So exactly we are going to create that in this tutorial. Before we start our coding, let me introduce you something. This course is part of my Mastering Python OpenCV with 31 real world project course. And as you can see, it is the bestseller course on Udemy. These courses come with various practical projects. Also I cover everything about OpenCV basics. Till today, it's come with 14 plus hour on-demand video and 76 downloadable resources. And time to time, I'm going to add new project on this course. So, what are you waiting for? Check out this course for once. I will provide the link at my description. So let's get started. So finally, we are in my Visual Studio code editor and I create a Python file app.py. With that, I import Haar Cascade file for face detection. And we already learned about Haar Cascade file in our previous tutorials. So I'm not going to explain it here. What can we do with that? So at first, I'm going to import this CV2 module. So I'm going to type import CV2. After that, I'm going to load the Haar Cascade file. For that, I'm going to type a single line comment, load Haar Cascade for face detection. And I'm going to define a variable. And our variable name is face cascade. Face cascade equal to here we need to use a function from CV2. So type CV2 dot cascade classifier. Then inside the round braces, here we need to provide the file path CV2 dot data dot Haar Cascade. And then I'm going to use concatenation sign and we need to provide, so inside the double quotes, I'm going to provide the file path. So I'm going to copy the file name and I'm going to put the XML file name at that position. .xml. That's it. This cascade classifier loads a P10 Haar Cascade model for face detection. And this XML classifier file is trained to detect human faces. After that, I want to use our webcam. So for that, I'm going to define a variable. And our variable name is cap. Cap equal to cv2.video capture method. And as a source, here I pass 0 because I have only one webcam in my computer. If you use multiple webcam and you want to access the another webcam, then you can change the number. Then we need to read the frames using the while loop. I want to read every frame from the video capture file. So here I'm going to type while true. Then inside this while loop, I want to read the frame. So type cap dot read method. And as you know, this cap dot read method return total 2 result. It return a boolean number and a frame. So to store the boolean number here I'm going to define a variable underscore. Otherwise you can name it ret, comma, and to store the frame I'm going to type frame. It's return true if the frame is captured successfully, and in the frame variable it's going to return the actual frame from the webcam. After that I'm going to set an if condition. So type if not frame, if not it's successful rate, then inside the if condition I want to break the loop, break. After that we need to convert the frame to grayscale for detection. So I'm going to define a variable gray equal to cv2 dot cvd color. Then inside the round braces, first I'm going to pass the actual frame, then I'm going to pass the color code cv2.color bgr to gray. By default, as you know, OpenCV read our frame into BGR mode. So we convert the frame into gray image. Next, we need to detect the faces using detect multiscale method. For that, I'm going to define a variable called faces. Faces equal to face cascade dot detect multiscale. And inside the round braces, first I'm going to provide the gray image, comma, then we need to set the scale factor. I'm going to set it 1.3. Then I'm going to set the minimum neighborhood. Minimum neighbors, I'm going to set it 5. Now the question is, what that means? Detect multiscale, find the faces in the image. And here I use another parameter, scale factor 1.3. It means how much the image is reduced at each scale. If you use smaller value, then it's going to give you more accuracy, but it can make you slower. And also we set minimum neighbor attribute 5. It is for the higher value. It's going to return fewer detection but more reliable. Now this method going to return total 4 value. It's going to return a content list of rectangle, x-axis, y-axis, width and height. For each detected face, it's going to return the starting point. I want to say the x-axis and y-axis point. Then it's going to return the width of the face and height of the face. Next, we need to blur the detected face. For that, I'm going to use a for loop. So I'm going to type here. I'm going to type for inside the round braces x-axis, y-axis. This is the starting point of the image, and then width and height. As I told you earlier, this method return total 4 value: x-axis, y-axis, width and height in faces. Then inside this for loop, we need to extract the face area. I want to say the region of interest. So I'm going to define a variable face ROI. Face ROI equal to frame. Basically, I draw a frame layout in a face, and to draw the frame layout, we need x-axis and y-axis. And to draw the frame layout, we need the starting point at the end point. So here we calculate the start point, and also we calculate the end point. After that, after extract the face area, I want to apply Gaussian blur. For that, I'm going to define another variable, blurred face. Blur face equal to cv2 dot Gaussian blur. Then inside the round braces, I'm going to pass the exact position of our face. So I'm going to pass this variable face region of interest, and we apply the blur. Here we define the size of the blur kernel. It must be odd number. If we use larger value, then it's going to return more blur. And then we pass 30. It is for standard deviation of Gaussian kernel. After that, we need to place the blur frame into the original image. Basically, I want to say we need to replace the region of interest area with the blur face. So here I'm going to type frame inside the round braces, starting position and end position of this frame equal to blur face. Basically, we apply this blur in this frame, in this frame area. Now, outside the for loop, I am going to display the output. To show the output, I am going to type cv2.imShow method, and our window title is live face blur privacy filter, and I'm going to pass the actual frame. And to quit the program, I'm going to set the if condition. So I'm going to type if cv2.wait key, I'm going to waiting for 1 millisecond equal to ordq. Then inside the if condition, I'm going to break the loop. And at last, I'm going to release our camera. I want to release our camera frame. Cap dot release method. And I'm going to destroy all the windows. So I'm going to type cv2 dot destroy all windows. And I'm going to save this file. So this is it. Now let's save the file and run this code in my terminal and see is it work properly or not. So I'm going to hit the run button, and I'm going to wait for some time to start our webcam. So after waiting for some time, as you can see, it start my webcam and you can see my blur face. It add a Gaussian blur to my face. If I move my head, also you can notice our face blur move with that. So this is how we can create live face blur privacy filter with the help of Haar Cascade file. So this is it for this tutorial. Thanks for watching this video. Stay tuned for our next project.